Very good morning, students. For this lecturing video session, I am going to give a brief introduction about the kinetics of rigid body. Okay. So in the previous lecturing video session, I have explained about the kinematics of rigid body, isn't it? So for this lecturing video, I am going to cover up the kinematics of rigid body. So the kinetics of rigid body is dealt with the geometry of motion with respect to the cause of motion, which is the force of translation and moment due to the force for rotation. Right. So the kinetic analysis of rigid body is done by following principles. Right. There are three principles there as far as the kinetics of rigid body is concerned. Rigid body motion is done by the following principles. The first one is D'Alembert's principle or Newton's law. Okay. D'Alembert's principle. Okay. In other words, it can be called as dynamic equilibrium or force method. Force method. Okay. The second one is impulse and momentum principle. Or moment of momentum principle. The third one is work energy principle or the energy method. So these are the three principles. With the use of these three principles, the kinetics of rigid body problems are solved. So first let me just explain the D'Alembert's principle or the dynamic equilibrium or the force method. See, according to the force method, that is D'Alembert's principle, a rigid body in plane motion may be considered to be in dynamic equilibrium. Dynamic equilibrium under the action of inertia force. So as you know that inertia force will act against the motion, that's the opposite of the motion. So therefore it carries the minus sign. So m into a in x direction and minus m in acceleration in y direction. Okay, and the inertia torque which will act against that is opposite of the rotation, right? So which can be entered as Ig alpha. This Ig alpha. So the equations can be summation f of x minus m a x equal to 0, or in other words, sum of horizontal forces minus mass into acceleration in x direction. So next, sum of forces in y direction minus mass into acceleration in y direction equal to, or in other words, sum of vertical forces minus m into a in y. So this can be considered as equation 1. This is equation 2. See, as far as the moment is concerned, sum of moment g minus ig alpha equal to 0. This is that equation. So in the above equations, minus max minus may are the inertia forces in x and y directions respectively, and the minus ig alpha is the inertia torque about the axis of rotation. So it should be remembered that the inertia force should be applied in the opposite direction of linear acceleration, right? And the inertia torque should be applied in the opposite direction of the angular acceleration. These two equations can be used for the inertia forces, that is a linear acceleration, isn't it, in x and y directions. When you talk about the equation 3, there is the inertia torque, which is the opposite direction of the angular acceleration. So this is the D'Alembert's principle. When you talk about the energy method, which is the work energy. So second one is the impulse, isn't it? So let me just start with the impulse momentum. So after completing this, I will move to the energy method. Okay. So impulse and momentum principle. See, the moment of momentum or the impulse and momentum principle or the angular momentum, this also called as angular momentum. Okay. So the moment of momentum may be defined as the product of mass, moment of inertia and the angular velocity. Okay. So the moment of momentum, it may be defined as the product of mass, moment of inertia and the angular velocity of a rotating body, rigid body. So this is also known as the angular momentum, isn't it? So then the moment of momentum or the impulse momentum, or impulse and momentum principle equal to I into omega. So I is nothing but the mass moment of inertia of the body about the axis, and omega is the angular velocity of the rotating body about an axis. Right. So the condition 1, when the motion of the body, the case 1 or the condition 1, motion of rigid bodies in pure translation, when it is in pure translation, it can be written as sum of forces into T equal to m into v minus u. So summation F equal to it can be either horizontal forces or vertical forces. It can be either sum of horizontal forces or sum of vertical forces. Okay. So the case 2, the motion of the body or the rigid body in pure rotation. So sum of moment into T equal to inertia, the angular velocity, that is final angular velocity minus initial angular velocity. So mg is nothing but the resultant momentum, right, about the mass center g, and t is nothing but the time, and ig is nothing but the mass moment of inertia of the body about g, and this is the final angular velocity omega, and omega o is the initial velocity. Okay. So for the case 3, motion of rigid body in plane motion. So when the body is in plane motion, that is the combined translation and rotation. So here this is pure translation, and the case 2 it's a pure rotation, right? So when it comes to plane motion, this is general plane motion is a combination of the rotation and the translation, isn't it? So it's the impulse momentum equation can be mentioned as sum of forces, that is vertical or horizontal, into t plus sum of moment g into t equal to, right, sum of mass into v minus u plus sum of inertia, that is mass moment of inertia, into omega minus omega. So these are the 3 formulas which you need to remember to solve a problem for the impulse momentum by using the impulse momentum principle. Okay. So this is for the angular momentum or momentum or impulse momentum principle. When it comes to the energy method or the work energy principle, so here this work energy is nothing but the work done and the change in kinetic energy, isn't it? So when you talk about the condition 1, so that is a case 1, the pure translation, when the motion of the body, motion of rigid body in pure translation, that is sum of force into displacement equal to 1 by 2 m into final velocity minus initial velocity, where sum of force equal to sum of horizontal force or sum of vertical forces. So this is case 1 where there is no rotation, it's a pure translation, then this is the formula to be used. The case 2, when the motion of rigid bodies in pure rotation, then it could be sum of the resultant moment about the mass center g into theta, that is angular displacement, equal to 1 by 2 ig omega square minus omega o square. So this is pure rotation. Okay. So case 3, the motion of the body in plane motion, motion of rigid bodies in plane motion is nothing but the combination of translation and the rotation, isn't it? So then the work energy equation for the above cases can be combined. So these two cases we combined. So sum of forces into S plus sum of moment into angular displacement equal to 1 by 2 m v square minus u square plus this one ig by 2 omega square minus omega o square. So these are the three formulas which you need to remember for the work energy principle or the energy method, right? So now the comparison between the linear motion and the rotational motion. Okay. Comparison between linear and the angular or rotational motion. Okay. So first point of comparison. Next one is linear motion. Next one is the angular motion or rotational motion. So, serial number. First one, the force which caused the motion. Force which caused the motion. Force causing the motion. So F is equal to ma. So as far as the angular is concerned, m is equal to I into alpha. Second one, momentum. Momentum m into v. When it comes to angular or rotational moment, I into omega. Third one, inertia force. For the linear, it is F is equal to ma, right? When it comes to angular, it is I into alpha. Fourth one is work done. Work done is force into displacement, isn't it? Here, moment into angular displacement, because it is angular motion or the rotational motion. The kinetic energy. As far as kinetic energy is concerned, of mv square for the linear motion. When it comes to angular or rotational moment, of I omega square. Right. Sixth one, impulse moment equation. Impulse momentum equation. That is integral of T1 to T2 force into dt equal to m into v minus u. So when it comes to the angular motion or rotational motion, this T1 to T2, that is mg into dt equal to ig omega minus omega o. Okay. So next formula for the work energy principle or the energy method, work energy equation. So which is sum of forces into displacement equal to 1 by 2 m v square minus u square, isn't it? So when it comes to angular, it is sum of moment into angular displacement equal to 1 by 2 the mass moment of inertia into the angular velocity, initial the final angular velocity and the initial angular velocity. So these are the formulas which you need to remember it to solve a problem from the kinetics of rigid body. Okay. So the D'Alembert's principle mainly for the problem solving. So D'Alembert's principle is used problems involving force or moment force or moment, and linear or angular acceleration. Okay, so the D'Alembert's principle is used to solve the problem for where the force or moment and linear or angular acceleration is involved. When it comes to impulse and momentum principle, so the problems involving time, force or moment, and linear or angular velocity. Okay, this is for the angular momentum principle or impulse and momentum principle, right? And more moment of momentum principle. When it comes to the work energy principle or the energy method, work energy principle. So this work energy principle is used to solve the problems involving force or moment, then linear or angular velocity, and linear or angular displacement. So you have to just memorize these formulas, and you have to just remember this. So D'Alembert's principle is used to solve the force or moment and linear or angular acceleration. Then the impulse and momentum principle is used to solve the problem which involving time, force or moment, and linear or angular velocity. When it comes to the energy method or the work energy principle, so it is used to solve the problems for the force or moment or linear or angular velocity and the angular or linear displacement. Right? Hope you have understood the essence or the fundamentals of the three principles which I taught you, which is chapter kinetics of rigid body. Thank you.